From the smallest atom to the largest galaxy, the universe is a vast and intricate tapestry woven with the threads of mathematics. Every particle, every star, and every galaxy follows the rules and patterns dictated by mathematical principles. Mathematics underpins the very fabric of our universe. It is the invisible force that governs the laws of physics, the structure of molecules, and the orbits of planets. Without mathematics, our understanding of the universe would be incomplete and fragmented. It is the language of nature, a powerful tool that allows us to understand and describe the world around us. Through mathematical models and equations, we can predict natural phenomena, from the trajectory of a comet to the growth patterns of plants. Since the dawn of humanity, we have striven to decipher this language, to unlock the secrets hidden within its elegant equations and theorems. Early humans used simple counting systems to keep track of their resources, marking the beginning of our journey into the realm of numbers. This essay embarks on a journey through the fascinating history of mathematics, exploring the key milestones and the brilliant minds that have shaped this field. From the ancient Babylonians and Egyptians who developed early arithmetic and geometry, to the Greeks who laid the foundations of modern mathematics with their rigorous logical proofs. From the rudimentary counting systems of our ancestors to the abstract complexities of modern mathematics, each step has brought us closer to unraveling the mysteries of the cosmos. The invention of the abacus, the development of algebra, and the discovery of calculus have all been pivotal moments in this ongoing quest. Each step has brought us closer to unraveling the mysteries of the cosmos. The invention of the telescope allowed us to see the mathematical order in the heavens, while the particle accelerator has revealed the mathematical structure of the subatomic world. Join us as we trace the threads of mathematical thought through time, witnessing the birth of new ideas and the evolution of this fundamental discipline. We will explore the contributions of mathematicians like Euclid, who wrote The Elements, a comprehensive compilation of the knowledge of geometry, and Isaac Newton, whose laws of motion and universal gravitation are still taught today. Along the way, we will encounter the giants of mathematics, whose insights and discoveries have illuminated our understanding of the universe and our place within it. Figures like Carl Friedrich Gauss, known as the Prince of Mathematicians, who made significant contributions to number theory, and Emmy Noether, whose work in abstract algebra and theoretical physics has had a profound impact on modern science. Prepare to be amazed by the power and beauty of mathematics, a subject that continues to inspire and challenge us today, just as it has for millennia. In modern classrooms, students grapple with the same concepts that puzzled the great minds of the past, while new mathematical discoveries drive technological advancements and open up new frontiers of knowledge. Mathematics is not just a subject to be studied. It is a living, breathing entity that evolves and grows, constantly pushing the boundaries of what we know and what we can achieve. Imagine a world without numbers, without the ability to count, measure, or quantify. It's hard to fathom, isn't it? Numbers are so ingrained in our daily lives that we often take them for granted. This was the reality for our early ancestors, who lived long before the invention of written language. They navigated their world without the numerical systems we rely on today. Yet, even in the absence of formal mathematical systems, they possessed a rudimentary understanding of mathematical concepts. They observed patterns in nature, such as the changing seasons and the cycles of the moon. Evidence suggests that early humans used bones and other objects to keep track of quantities, perhaps for trading or tracking the lunar cycle. These tally marks on bones are some of the earliest known records of counting. These early attempts at counting were likely limited to small numbers, but they represented a crucial step in the development of mathematical thought. Imagine the significance of being able to count your livestock or measure the days until the next full moon. As human societies evolved, so did their need for more complex mathematical systems. Early humans began to use counting beads and other tools to keep track of larger quantities. These tools were primitive by today's standards, but they were revolutionary at the time. They allowed early humans to record and communicate numerical information in a way that was previously impossible. As human societies became more complex, so too did their mathematical needs. Agriculture, trade, and construction all demanded more sophisticated ways of counting, measuring, and calculating. The ability to measure land, track seasons, and trade goods was essential for the growth of early civilizations. This led to the development of the first true number systems. These systems were not just about counting, they included ways to measure and calculate, which were crucial for building structures and managing resources. The development of written number systems marked a pivotal moment in human history. It allowed for the recording and transmission of numerical information across generations, paving the way for more advanced mathematical concepts. These early systems, though rudimentary compared to modern mathematics, were a testament to human ingenuity. They laid the groundwork for the complex mathematical theories and practices that would follow. These early mathematical tools and writings were the building blocks of a new way of thinking. They allowed humans to solve problems and make sense of the world in ways that were previously unimaginable. They paved the way for the development of more abstract mathematical concepts. Early scholars began to explore ideas that went beyond simple counting and measuring, delving into the realms of geometry and algebra. These early advancements laid the foundation for the incredible achievements of later civilizations. From the pyramids of Egypt to the aqueducts of Rome, the mathematical knowledge of early humans was instrumental in shaping the world we live in today. Today, we continue to build on the mathematical foundations laid by our ancestors. Modern mathematics is a vast and complex field, but it all began with those early attempts to count, measure, and understand the world around us. As we look to the future, the importance of mathematics in our lives will only continue to grow. From technology and engineering to finance and medicine, math is at the heart of innovation and progress. So the next time you solve a math problem or use numbers in your daily life, take a moment to appreciate the long journey of mathematical discovery that has brought us to this point. It's a journey that began thousands of years ago with the simple act of counting. The ancient Egyptians were masters of mathematics, using their knowledge to build colossal structures, manage vast empires, and understand the heavens. Their mathematical prowess was not just limited to grand architectural feats, but permeated every aspect of their daily lives and spiritual beliefs. Their civilization flourished along the Nile River, where they developed a sophisticated understanding of geometry, arithmetic, and algebra. The fertile banks of the Nile provided the perfect environment for the growth of a complex society that required advanced mathematical skills to manage agriculture, trade, and construction. One of the most impressive examples of Egyptian mathematics is the Great Pyramid of Giza. This architectural marvel, standing at an original height of 146.6 meters, was the tallest man-made structure in the world for over 3,800 years. This monumental structure, built as a tomb for the pharaoh Khufu, is a testament to the Egyptians' mastery of geometry and their ability to make precise calculations on a massive scale. The pyramid's alignment with the cardinal points and its nearly perfect proportions demonstrate an advanced understanding of mathematical principles. The Egyptians also developed a practical system of mathematics for everyday use. In bustling markets and busy construction sites, mathematics was an essential tool for trade, commerce, and building. They used a decimal system much like our own and were adept at performing arithmetic operations such as addition, subtraction, multiplication, and division. Their number system was based on the number 10, likely influenced by the 10 fingers on human hands, making it intuitive and practical for daily use. They even had a rudimentary understanding of fractions, which they used for tasks such as dividing land and measuring grain. This was particularly important in a society where agriculture was the backbone of the economy, and precise measurements were crucial for fair distribution and trade. Beyond its practical applications, Egyptian mathematics also had a spiritual dimension. The Egyptians believed that the universe was governed by a divine order, and mathematics was a way to understand and connect with this cosmic harmony. They saw mathematical principles as reflections of divine order, believing that understanding these principles could bring them closer to the gods. Temples and religious structures were often designed with precise mathematical ratios and alignments, symbolizing the connection between the earthly and the divine. This reverence for mathematics is evident in their intricate astronomical calculations and their use of geometry in religious rituals. The Egyptians meticulously charted the stars and planets, using their observations to create calendars and predict celestial events, which were integral to their religious and agricultural practices. Their ability to blend practical and spiritual aspects of mathematics is a testament to their profound understanding and respect for the subject.